Hi there. Now here we see a function, or I've actually given you an equation or a formula defining the function. We can answer all these questions using the formula, but we can also answer them by looking at the graph of the function. So this is what you would get if you put that formula into a graphing app and asked it to draw the graph of this function. What's the value of this function of f when x is 0? In other words, what is f of 0? Well, we can tell that from the formula by plugging 0 in for x and doing the calculation. 0 squared is 0, 4 times 0 is 0, 16 minus 0 is 16, and the square root of 16 is 4. But we can also see that right away on the graph, because if you look for the point on the graph where x is 0, the y-coordinate of that point is 4. What's the value of f when x is negative 2? I can see it right away on the graph. It is 0. You can try it in the formula. What's the value of f when x is 3? Well, what's the point on the graph with an x-coordinate of 3? I don't think there is one. There is no point on the graph where x is 3. So f of 3 is undefined. Now, what would happen if we tried plugging 3 into the formula? 3 squared is 9, 4 times 9 is 36, 16 minus 36 is negative 20, and the square root of negative 20 is not a real number. We can't take square roots of negative numbers unless we're willing to allow imaginary numbers, and we're not dealing with those in this chapter. They don't show up on graphs like this. What is the domain? What are the x-coordinates that make up the points on the graph? Well, they go from negative 2 to 2. What is the range? What are the y-coordinates that make up points on the graph? They go from 0 up to 4. And we could also talk about symmetry. Looks to me like this is symmetric with respect to the y-axis. The y-axis runs right through the middle of the graph, cutting it into two identical halves that are mirror images of one another. And we could ask about intercepts. Looks like we've got x-intercepts at negative 2 and 2, and a y-intercept up here at 4. Okay, here's another function to play with. Here's the formula, the equation defining the function, and here's what the graph looks like. The value of this function when x is 3 would be 3. There it is on the graph. What about when x is 0? Undefined. There is no point on the graph where x is 0, and if you try plugging 0 into the formula, again, that would involve taking the square root of a negative number. What's the value of f when x is negative 5? Well, I can see it on the graph right there. It's negative 1. And I could also get that by plugging negative 5 into the formula. What's the domain? Well, the points that make up this graph have x-coordinates that go from negative infinity to negative 3, and then from 3 on up to positive infinity. And the range, the y-coordinates of the points that make up this graph, go from, there's no limit to how far down they go. If we zoom out, we'd see points that go as far down as we want. But there is a limit to how far up they go. So the y-coordinates run from negative infinity up to 3. So that's the range, negative infinity up to and including 3. And while we're at it, the graph is symmetric with respect to the y-axis, and it's got x-intercepts here and here. I can't tell exactly where they are, but it's somewhere between negative 4 and negative 5, and then somewhere between positive 4 and positive 5. So positive and negative 4 point something. And there is no y-intercept. It never touches the y-axis. How about this function? What's the value of f when x is 0? You should be able to see right away from the graph that it is negative 1. What's the value of f when x is negative 2? 0. What's the value of f when x is 4? 3. What is the domain? All real numbers, everything from negative infinity to infinity. On the part of the graph that we can see here, we only see x-coordinates that range from negative to positive about 5.5. But that's just because we cut things off here. Really, it keeps on going. So if we zoom out, there's no limit to how big or how small the x-coordinates can get. And what about the range? Remember, that refers to the y-coordinates. So the y-coordinates never get any lower than negative 1, but there's no limit to how far up they go. So the range is from negative 1 to infinity. And this is also symmetric with respect to the y-axis. It's got x-intercepts at negative 2 and positive 2, and a y-intercept here at negative 1. Now remember when we were talking about what counts as a function. One definition was it's a set of ordered pairs where no two of the pairs have the same first coordinate, but different second coordinates. So that means if you're looking at the graph of a function, you can't have 2 points on the graph that have the same x-coordinate but different y-coordinates. And that would happen if the points were directly above one another. If they had the same x-coordinate, they would be on the same vertical line as each other. So we have the vertical line test for how you can look at a graph and see whether or not it's the graph of something that counts as a function. So the vertical line test says that in order to be the graph of a function, any vertical line can only touch the graph once. If there's any way that a vertical line could touch the graph at more than one point, it's not a function. Let's look at some examples. So y equals the square root of x plus 5. The graph looks like this. Does it pass the vertical line test? Yes. Any vertical line would touch this graph at only one point, or maybe no points at all, but never at more than one point. What about 2x plus 3y equals 4? Does that pass the vertical line test for being a function? Yes. So that one is a function. It's not written in the form of a function, but we could solve that equation for y, and then it would have y as a function of x. So it does count as a function. By the way, neither of these have any of the kind of symmetry we talked about, and we could find the x-intercept and the y-intercept if we wanted to. But let's look at some more examples of the vertical line test. This circle is the graph of the equation x squared plus y squared equals 4. Does that define a function? Is y a function of x? Well, no. Looks like a vertical line touches this graph at more than one point. So there's more than one y for the same x. And if that happens, y can't be a function of x. What about this one? The equation here is xy minus x minus 2 equals 0. But here's what the graph looks like. Does it pass the vertical line test for being a function? Yeah. Any vertical line is only going to touch this graph at one point at a time. So that is a function. It's not written in the form of a function when you look at the equation, but we could rearrange things so that it was solved for y. Get a little bit complicated, but we could do it. Okay, what about this one? Y equals x cubed minus 3x plus 2. Well, the way the equation's written, it looks like a function. And from the graph, yeah, it passes the vertical line test. Any vertical line only touches the graph once. So that one is a function. What about this one? Well, looks like You can have vertical lines that touch the graph at more than one point. Some vertical lines would only touch it at one point, but some of them touch it at 3 different points. So it's not a function. You know what? I'm going to end this video here, and then I'm going to come back and talk about odd and even functions and how to recognize those. And we also still have to talk more about increasing and decreasing functions. So see you in the next video.